The message arrived quietly, almost unnoticed amidst the constant stream of data flowing in from observatories around the globe. It was a subtle signal, a whisper from the cosmos, just a string of data, seemingly insignificant at first glance, originating from a robotic telescope nestled high in the Chilean Andes. It was flagging a new object, a celestial wanderer, slowly moving against the backdrop of distant stars. The automated system had detected something unusual, something that warranted further investigation. At first it was just another faint speck of light, easily dismissed as a distant star or a minor asteroid. One of hundreds, perhaps thousands, that the telescope detected that very night. The vastness of space is filled with countless objects, most of which pose no threat to us. But this one was different. There was something peculiar about its trajectory, its speed, its very nature. Its calculated path projected into the future showed a chilling possibility. It intersected with Earth's orbit. This wasn't just another near miss, this was a potential collision. Early calculations, based on the limited initial data, pointed to a chilling possibility, a scenario that sent ripples of concern through the astronomical community. The probability was low, but the potential consequences were catastrophic. This object, now officially designated 2024 YR4, became the focus of intense scrutiny. The projections indicated that it could cross Earth's orbital path in December 2032. 8 years. 8 years to refine the calculations, to understand the threat, and, if necessary, to devise a plan. We live our lives day in and day out, largely oblivious to the cosmic shooting gallery above us, the constant dance of celestial bodies, where asteroids and comets, remnants from the formation of our solar system, silently pass by, some incredibly close, others at a safe distance. Most are harmless, small fragments of rock and ice that burn up harmlessly in our atmosphere as shooting stars. But sometimes, just sometimes, the universe deals a dangerous hand, presenting us with a celestial object that poses a real and present danger. 2024 YR4 is that threat, a stark reminder of the forces at play in our solar system. A reminder that space is not a gentle, welcoming place, but a realm of immense power and potential danger. The news, initially confined to the scientific community, spread slowly, from astronomers poring over data to science journalists carefully crafting their reports, and eventually to the public at large. Igniting a wave of anxiety, a collective unease that rippled across the globe. Headlines screamed, amplifying the fear and uncertainty. "City-killer asteroid on collision course with Earth," one particularly sensational headline blared. Scientists, ever mindful of their responsibility to the public, urged calm and caution. But the seed of fear, once planted, is difficult to eradicate. This isn't science fiction, a fantastical tale of impending doom. It's the reality of planetary defense today, the ongoing effort to identify, track, and potentially mitigate the threat of near-Earth objects. We can see these threats coming thanks to advancements in telescope technology and dedicated sky surveys. But seeing is only the first step, the initial stage in a complex and challenging process. The real test is understanding the danger with precision, accurately tracking its trajectory over time, and having a well-defined plan in place should intervention become necessary. The story of 2024 YR4 is not just about a single asteroid, it's about our collective response as a species to a cosmic challenge that transcends national borders. It forces us to look up, to contemplate the vastness of the universe, and to confront our place within it. This is a wake-up call, a cosmic message delivered from the depths of space, urging us to take our planetary defense seriously. Our planet, this pale blue dot suspended in the void, is fragile, vulnerable to the forces of the cosmos, and it's ultimately up to us, the inhabitants of this planet, to protect it from harm. The countdown has begun, and the clock is ticking. The story of 2024 YR4 begins on a seemingly ordinary night, under the vast expanse of the cosmos. It was a night like any other, with countless stars twinkling in the inky blackness, their light having traveled unimaginable distances to reach our eyes. At Cerro Tololo Observatory in Chile, a place renowned for its pristine skies and cutting-edge astronomical instruments. Perched high in the Andes Mountains, this observatory provides a unique window into the universe, far from the light pollution that obscures the view in more populated areas. But the discovery of 2024 YR4 wasn't the result of a lone astronomer peering through a telescope. Instead, it was found by a sophisticated algorithm, a piece of software designed to tirelessly scan the heavens. This algorithm was sifting through images captured by the Dark Energy Camera, a powerful instrument attached to the Blanco telescope. This camera is designed to map the universe and uncover the secrets of dark energy, but it also serves as a vigilant sentinel, constantly watching for potentially hazardous asteroids. The software's primary job is simple, yet crucial: to spot things that move against the backdrop of distant stars and galaxies. It's a cosmic game of spot the difference, identifying objects that shift their position from one image to the next. And that's precisely what it did. The algorithm flagged a faint dot, a tiny speck of light barely brighter than the surrounding background noise. It was a needle in a haystack of cosmic proportions. This seemingly insignificant detection triggered a chain of events, as the software automatically sent an alert to the Minor Planet Center, the official clearinghouse for all asteroid and comet discoveries. This alert acted as a cosmic bat signal, and astronomers worldwide received the message, a call to action in the face of the unknown. Observatories around the globe, both professional and amateur, quickly pointed their telescopes towards the designated patch of sky to confirm the existence of this new object. Each observation, each captured photon of light, helped to gather more data about this mysterious visitor from the depths of space. With each new data point, scientists were able to refine the asteroid's orbit, tracing its path through the solar system with increasing precision. But as the orbit became more well-defined, the picture that emerged grew more alarming, painting a potentially dangerous scenario. This wasn't just another harmless asteroid residing safely within the main asteroid belt, far from Earth's orbit. Instead, it was classified as a near-Earth object, an asteroid whose orbit brings it into the vicinity of our planet. The discovery transformed into a race against time, a desperate attempt to understand the true nature of this celestial interloper. The more data they collected, the clearer the trajectory became, and the more concerning the potential implications appeared to be. Sophisticated computer models were employed to simulate thousands upon thousands of possible paths that 2024 YR4 could take through the solar system. And the results were unsettling. Too many of these simulations pointed towards a close approach to Earth in late 2032, a date that suddenly loomed large in the minds of astronomers. Automated asteroid monitoring systems such as NASA's Sentry swung into action, analyzing the available data and assessing the potential threat. Based on the initial observations, the Sentry system flagged 2024 YR4 as a top risk, a designation that demanded immediate attention and further investigation. While the risk of an actual impact wasn't certain and remained a matter of probability, the potential consequences were severe enough to prioritize 2024 YR4 for urgent and continuous observation. The world's largest and most powerful telescopes were tasked with tracking this potentially hazardous asteroid, dedicating valuable observing time to unraveling its secrets. And so, the long watch had begun, a vigil over the skies as humanity braced itself for the unknown. Humanity was now on high alert, united in its awareness of a potential threat lurking in the vastness of space. The cosmic clock was ticking, counting down the days, months, and years until 2024 YR4 would make its closest approach to Earth. Astronomers estimated 2024 YR4's size at about 250 meters, roughly the size of a sports stadium. Not a planet killer, but a city killer. If it struck, the energy released would dwarf any nuclear weapon, carving a crater kilometers wide and vaporizing everything at ground zero. The blast wave would flatten cities, ignite fires, and trigger earthquakes. Dust thrown into the atmosphere could dim the sun and disrupt global weather, leading to famine. The death toll could reach millions, with billions affected by the aftermath. Objects this size are hard to detect, yet numerous. 2024 YR4 is a stark reminder: these hidden dangers lurk in the dark. Finding them before they find us is essential. December 26, 2032, 2024. YR4 will make its closest approach to Earth, about 150,000 kilometers away. That's less than half the distance to the Moon, a cosmic near miss. But that number is just the center of a range. The true path could be closer or farther. Astronomers call this the uncertainty region. The worst-case edge of that region still grazes Earth. The flyby is critical. Earth's gravity could alter the asteroid's path, potentially setting up a future impact. Mapping these gravitational keyholes is a top priority. For now, the odds of impact are low, but every new observation matters. The next few years will be a tense waiting game. Is this a harmless passerby or a harbinger of doom? In late 2026, 2024 YR4 will slip behind the sun, vanishing from our view for 3 years. During this blackout, uncertainty about its path will grow. We'll be flying blind, unable to refine its trajectory. Small forces like the Yarkovsky effect, a tiny push from sunlight, could subtly change its orbit. When it re-emerges in 2029, the first new observations will be crucial. Has it drifted towards safety or danger? The astronomical community will scramble to reacquire and track it. The suspense will be palpable. Not all asteroids are alike. Composition matters. Stony rubble piles can explode in the atmosphere like the Tunguska event, flattening vast areas. Metallic asteroids, like the one that made Meteor Crater, punch through to the ground, causing even greater devastation. 2024 YR4 at 250 meters could be either. If it's stony, expect a massive airburst. If metallic, a ground impact and a crater kilometers wide. Determining its makeup is critical for planning any defense. Astronomers will use spectroscopy to analyze its surface from afar. The difference could mean the fate of millions. The investigation is urgent. If 2024 YR4 hits, location is everything. Most likely it would strike an ocean, triggering a mega tsunami. Waves hundreds of meters high, devastating coastlines worldwide. The climate could be disrupted by water vapor and salt blasted into the atmosphere. A land impact, though less likely, would be catastrophic, obliterating cities, igniting firestorms, and causing global cooling. Even a remote strike would have worldwide consequences. The economic and social fallout would be immense. This is the planetary lottery we play. The stakes, nothing less than civilization itself. The threat is real. Preparation is everything. Unlike the dinosaurs who were caught completely unaware, we have options. We have the capacity to detect, analyze, and ultimately, to act. The question isn't whether we can defend our planet, but how we choose to do so. With years of warning, deflecting an asteroid, altering its trajectory ever so slightly is not just theoretically possible, it's within our grasp. Early detection is paramount, giving us the time we need to prepare and execute a successful deflection mission. The goal isn't to destroy it in a dramatic explosion which could create even more problems, but to nudge it, to gently guide it onto a safer path. This requires incredible precision, the ability to change its velocity by mere millimeters per second. A tiny adjustment, applied over a long period, can result in a significant change in its ultimate trajectory. The most proven method currently available to us, the kinetic impactor, is a direct and relatively simple approach. It involves sending a spacecraft to intentionally slam into the asteroid, transferring its momentum and pushing it off its original course. NASA's DART mission, the Double Asteroid Redirection Test, successfully demonstrated that this method works, marking a major milestone in planetary defense. Another intriguing option, still in the conceptual stage but showing great promise, is the gravity tractor. This involves a heavy spacecraft flying alongside the asteroid, maintaining a close and carefully controlled proximity. The spacecraft's own gravity gently tugs on the asteroid, slowly but surely towing it into a new, safer orbit. This method is particularly appealing because it's precise and controllable, and it works well even for fragile rubble pile asteroids, which are loosely held together. In truly extreme cases, when all other options are exhausted and time is running out, a nuclear device could be used to vaporize part of the asteroid's surface. The resulting explosion would create a powerful thrust, pushing the asteroid away from its collision course with Earth. So, if we detect an asteroid like 2024 YR4 with years of lead time, giving us ample opportunity to prepare, kinetic impactors, delivering a precise and calculated nudge, or gravity tractors, offering a more gentle and controlled approach, are likely to be the best bets for a successful deflection. Careful planning, rigorous testing, and realistic practice scenarios are absolutely key to ensuring the effectiveness of any planetary defense strategy. The fundamental technology required to defend our planet already exists, developed through decades of space exploration and engineering innovation. The biggest challenge we face is not a technological one, but rather acting decisively and in time, before a potential threat becomes an unavoidable catastrophe. The clock is ticking, and the future of our planet may depend on our ability to respond effectively. What happens next? Observation is the priority. Every telescope will track 2024 YR4 until it disappears behind the sun. Astronomers will study its orbit, composition, and spin. Engineers will plan potential missions, kinetic impactor, gravity tractor, or both. Having plans ready means we can act fast if the risk rises. This is not science fiction, it's contingency planning. The lesson: planetary defense is essential. We must invest in new telescopes and practice deflection techniques. Public awareness and political will are vital. The threat is low probability, but high consequence. The story of 2024 YR4 is still being written. Will it be a close shave, or humanity's first great cosmic challenge? The answer will define our future.